So we're going to continue talking about exponential functions. So we want to create a table and graph the two functions, f of x equals 2 to the x, and g of x equals 1/2 to the x. So to make a table, let's just go ahead and use our graphing device. And we go to our y equals, and we put in 2 to the x, and then here we're going to do 1/2 to the x. And the second table, so we get our table of values. Looks something like this. So let's go ahead and graph each of these. So if we graph 2 to the x, which we actually did in the previous section, -3 is 0.125, a quarter, half, 1, 1 is 2, 2 is 4, and 3 is 8. We have a function that looks like this. And if we graph 1/2 raised to the x, that's our g, we have it -3, we're 8, -2, 4, -1, 2, 0, 1, 1/2, 2 a quarter, and an 8. And it looks something like this. So we notice these two curves have a symmetry across the y-axis. And it turns out that that's true, that the graph of f of x equals a to the x and g of x equals 1/a to the x are reflections across the y-axis. And the reason for that is 1/a raised to the x is the same as a to the -1 raised to the x. Because if we move our a from the denominator to the numerator, it makes its exponent negative. And then if we have a power raised to a power, we multiply. So that gives us a to the -x. So that would tell us that g of x is equal to a to the -x, which is f of -x. So using our shifting rules that we have, if you ever compose with a minus sign, this is a reflection across the y-axis. All right. So what we're going to do now is just make a laundry list of facts, things that are true about the exponential growth function. So first property is it is continuous. 2, it has domain all real numbers, so from -infinity to +infinity. Its range is going to be from 0 to +infinity, not including 0. 4, it has a horizontal asymptote at y is equal to 0. 5, it always contains the point 0, 1. and 6. If b is bigger than 1, the function is increasing. If 0 is less than b is less than 1, the function is decreasing. So these properties are taken as facts. We can use them and quote them as such. So if we're ever asked what the domain is, it's minus infinity to infinity. The range is 0 to infinity. But notice that only applies to this. In terms of what we've talked about before, this is our parent function. So as far as our shifting rules go that we've talked about in the previous section, remember that chart we had? We're going to use it again. And this is what our parent function looks like, is the graph in orange. We can apply all of our shifts to said function. All right, with all of these facts, we are now ready to do some examples. So it says use transformations to graph negative 2 to the x take away 5. So we know our parent function has to contain the function 0, 1. We know that we have a horizontal asymptote at y equals to 0. And this is our parent function. It comes along the x-axis, hits this, and goes up like this. So now we need to identify what's happening. So what does the minus sign out in front do? Well, that's going to reflect across the x-axis. And then the minus 5, we're going to shift down 5 units. So first thing we're going to do is reflect. So if we reflect the point 0, 1 across the x-axis, it becomes 0, negative 1. A reflection does not move the horizontal asymptote. That's our first thing. Now step 2 is we're going to shift it down 5 units. So if it's at negative 1 and goes down 5 units, it's going to go to negative 6. This will also shift down the horizontal asymptote 5 units. So our new horizontal asymptote is y equals to negative 5. So then our graph comes along the horizontal asymptote and then looks like this. So our graph contains the point 0, negative 6, has a horizontal asymptote of y equals negative 5, and was shifted down 5 units. So now we weren't asked this specifically, but what would its new range be? Well, what was our old range? It went from 0 to positive infinity. Well, when we reflected the graph, the red graph now has range from negative infinity to 0, because it goes up to its horizontal asymptote. And then, when we shifted it down 5 units, our range is going to go up to the horizontal asymptote. So we're going to go from negative infinity to negative 5. So our shifting rules will help us determine what the range is and the horizontal asymptote when this stuff gets moved around. All right, so on our first one, we have the negative sign, so that's going to be a reflection across x, so it reflects from 0, 1 to 0, negative 1, doesn't move our horizontal asymptote, so our graph would look something like this. In our second one, we have two things that are happening. We have the x minus 2 on the inside, so that's going to shift right 2 units. And then we have the minus 5 on the outside, and that's going to shift down 5 units. So if we take our graph and we know it starts at 0, 1, and we shift it right 2 units, we get this point. Our asymptote looks like this. Then we shift our asymptote down 5 units. That brings us down here. Shift this down 5 units. 1, 2, 3, 4, 5. We get our graph looks something like this. So that would be our exponential growth function shifted 2 units to the right and down 5 units. So once again, we weren't asked this, but in the first one, what would be our range over here? Well, it went down, so from negative infinity up to the horizontal asymptote, which is 0. Here, our graph is still going up, but our range is going to start at our horizontal asymptote, negative 5, and then it goes up forever to positive infinity. So in all those examples, we'll note that the horizontal asymptote was either where the range started or the range ended, and the other end was always positive or negative infinity. If we reflect across x, it's going to be from negative infinity to the horizontal asymptote. If we don't reflect across x, it's going to be from the horizontal asymptote to infinity. All right, so let's look at a couple more. So with example 3, we've got a couple more things going on. So our parent function is still our growth function, base 3. Now I've got this guy. So the negative 1/2 is actually going to be two things. So 1, since it's negative, it's going to reflect across the x-axis. 2, since it's 1/2 in magnitude, it's going to shrink by a factor of 1/2. Plus 4 on the outside is going to shift up 4 units. So if we start with our generic parent function, that's 3 to the x, first thing we need to do is reflect and then shrink. So if we reflect from positive 1 to negative 1, but then shrink by a factor of 1/2, it's going to be 1/2. It's going to do something like this. And then we need to shift our graph up 4 units. So we go up 1, 2, 3, 4. And we're still going to have our horizontal asymptote here. Our graph is going to look something like this. Example 4, it's going to be something similar. But we're going to have to do a little bit of algebra to probably help us out first. So if we look at this piece right here, we have 1/3 to the 2 minus x. So we can rewrite this as 3 to the negative 1 to the 2 minus x. And if we have a power raised to a power, we multiply their exponents. So that's negative 1 times 2 minus x, which is going to be negative 1 times negative x is positive x, and negative 1 times 2 is negative 2. So our function is actually f of x equals 3 to the x minus 2 take away 1. So this is very similar to one we did above, so that's going to shift right 2 units. And this guy is going to shift down 1 unit. So then, taking our generic function, we're going to shift right 2 and then go down 1